Welcome guys to today's class. In today's video, we want to see how to solve this problem we have when you have a circuit with identical cells. Yes, or identical EMF. Look at what we mean. For question number 1, 6 identical cells of EMF E and internal resistance R are connected in parallel. The net EMF and internal resistance of the combination will be what? You need to understand, assuming they didn't even give you expo to tell you that these are cells or these are EMF, how do we know that when you see a symbol that is talking about EMF? In one of our videos, we talk about when you have something like this, short terminal and long terminal. This is EMF, how it is. This is cell. This is a cell, and it is at this terminal that you see EMF located and internal resistance also located. It is at this terminal. So when you have the short terminal and the long terminal is EMF. But once we are talking about equal what? This is capacitor. Capacitor. Like this capacitor, how we represent it, because they are of equal size. But this one, this is short and this is long. Are you getting it? Then when you have something like this or something like this is what we call standard resistor. But when you have it like this is variable resistor or rheostat. So there is need for you to note how to identify any of these symbols. Yes. Now let's see how to solve this question. They said 6 identical cells. So once they are in parallel, what happens to their EMF? How do you get the total EMF when they are in parallel? It is important to note that when we have EMF, set of EMF arranged in parallel, their total or effective EMF will be one of that EMF. Don't just add them 1.1, 1.1, 1.1 and add them up. No, just take one. You see, the resultant EMF will be equals 1.1 volts because they are in parallel. So the total EMF will be same thing as one of the EMF. That is what we mean. Take one because they are in parallel. Yes, they are in parallel. So this circuit will be having only 1.1 volts, irrespective that there are many cells arranged in parallel. Yes, 1.1 volts. Then what about the internal resistance? Since they are in parallel, how many are there? 0.2, 0.2, 0.2, 0.2. You said internal resistance is one of it divided by how many are there? 4. How many are there? You put it n. So one of it divided by how many they are is what you use to get the what? The total R. Are you getting it? So one of it is 0.2. Total is what? 4. They are in 4. 1, 2, 3. This is external. This is external own. That is why I put this capital R. External stays here. You can't have internal resistance here. You can't have it. This is external own. From the symbol I just showed, this is a standard resistor. You know, so this is external resistor. Other ones here are the internal own. So this means this is your E, the first E, second E, where this is will be the corresponding arrow of it, corresponding value of R, internal resistor of this. Then this is E, this is E, this is R, this is E, and this is what? R. So note it. So we have gotten that the total EMF will be E, and the total internal resistor of it will be one of the resistor divided by how many they are, because they have identical cells. They have identical EMF and automatically identical internal resistor. So this is a case you should not forget, so to speak. So that means our answer today is it will have 1 E and R over how many there are? 6. So option C will be the answer. Now, since we have used these three to solve one, let's sort out these three. They say find the current in the circuit. We have gotten the total EMF and we have gotten our R. Remember that current is equal to total EMF all over R plus R. This is one of the formula we have in electricity. What is our E? 1.1. What is our R? The external resistor, which is what? 4. Plus what is our R? The small. You say 0.2 divided by 4. That will be giving you 0.05. 0.05. So you will compute it. I will be equal to 1.1 all over 4.05. 1.1 divided by what? That will be giving us 0.272 amperes. So you note it. This one will be in ohms. So you note it. Okay? That is how to sort out this. Now, when they are in series, when the identical cells are in, you can see they are like twins. They are in series. When they are in series, their total E will be what? The E1 plus E2 plus E3 ... And the total R will be equal to R1 plus R2 plus R3 ... That means how many are there? How many are there? Since they are identical, they will be having one value. E plus E plus E plus the next word E. That means we'll be having 4E. Whereas this one will be having what? They are identical. They are identical plus R equals to 4R. So how do we get them? We will say 4E, 4 times 1 of the E. E will be equals to 4.4. That is 4 times 1.1. Whereas R will be equals to 0.2 times 4. 0.8 ohms. How can we now get the current in this? Because they say find the current in this circuit. We will say the current is equal to E all over R plus R. What is our E? What is our E? Our E is 4.4 all over. Now we need to get our external resistance of the resistor. Now these resistors are in series. You use the normal way. When they are in series, you add. It's direct. Just add them together. Well, but when they are in parallel, we used to say 1 over R equals to 1 over what? 2 plus 1 over 2. Once they are in parallel, then our R will be equal to this plus this is 1. Everything will be 1 over what you got. So if you compute this now, it will be giving you 1. 1 over that 1 you got will be equal to 1. Or because they are 2, if they are in parallel, that is what we are checking. Once you have this in parallel, what you can do is you say R equals to 2 times 2, multiply the 2, all over add the 2. 2 plus 2. That will be giving you what? 1. You can use that method. But this case, we are having them in series. So you just add them. You just add it. This plus this is what? 4. You have it as 4 plus, what is your R? R is 0.8. So you will be having 4.4 all over 4.8. We use our calculator. 4.4 divided by 4.8. That will be giving us 0.917 amperes. So this is how to solve this question we have here. It's a very special question in electricity. So this is for this, why this is for this. Please don't forget it. If you find this video helpful, please do well to give me a like, click subscribe, or follow me on this platform: YouTube, Facebook, Instagram, TikTok by Chidons Daniel. Just use Chidons Daniel and follow me on any of those platforms. For TikTok, for YouTube, for Facebook, for what? Instagram, Chidons Daniel. Or when you type it, if you come to Instagram, you see it as the Chidons Academy class. When you come to YouTube, you have Chidons Daniel. When you come to TikTok, you have Chidons Daniel. And when we come to what? Which other one remain? Okay, TikTok, Chidons Daniel. YouTube, Chidons Daniel. When you type Chidons Daniel, you will see my page where I write the Chidons group. That is my main page, but this is just my Facebook. You understand? That is for Facebook. So once you type this, you will see Chidons Daniel. I think it's a unique name, so to speak, so that you follow our classes. You must see one or two class we will just posted there, so that you will be sure of where you are joining. Okay, thank you for watching today's video. See you in another class.